we're here at the RISC-V Summit in Barcelona, and I'm meeting up with Gerard Rauwerda, and he is working for Technolution. Now, we are talking about edge applications quite often, and edge applications is electronics somewhere deep in the field or whatever. But your company is taking a specific approach with edge application because for you the edge is in space. Am I right or wrong?
That's completely right.
Okay.
So we are bringing RISC-V technology to space. That's one of our ambitions. We have already RISC-V implementations for highly confidential security applications, and our goal is to bring this technology also to space.
So technology into space. I understood from our earlier conversation you're having a specific solution to combine sensors with different type of satellites or different type of hardware which is in space, making it a sort of a modular approach.
Yes, that's correct. So maybe I can explain it with this picture. Actually, if you have an instrument for a small satellite, an instrument is a sensor, and you need to bridge that sensor to a satellite. There are different types of sensors, there are different types of satellites, and what we have proposed is a modular electronics, so that we can bridge every type of sensor to every type of small satellite platform.
Okay.
The modular electronics means customizing the interface module, so that you can have different sensors connected to the system, but also customizing the interfaces towards the satellite platform. They're different for all kinds of satellites. But the heart of the bridging logic is a radiation-tolerant FPGA implementation. And inside that FPGA we have a RISC-V processor, which is a microcontroller that can be used to control the instrument, but also to do the communication with the satellite platform.
That is one of the reasons why you're here, of course, at the RISC-V Summit. Can I ask, because lots of companies are a member of RISC-V or are working or looking to work with RISC-V. How was that for you? It's a sort of a testimonial. How did you ended up with RISC-V?
Yeah, so actually we are one of the founding members of the RISC-V Foundation. So back in 2015, maybe already earlier, my colleagues were looking for a solution for a soft processor that they could use in all kinds of projects. We build a lot of technology based on FPGAs, but we don't want to stick to an FPGA vendor. So we would like to have a design that we can port to every brand of FPGA. And then what you need is a flexible soft processor solution, and then we got in touch with RISC-V. RISC-V is an open standard, so it's standardized, and that's important. And back then there was the wish that the RISC-V community would really grow as a big community. And nowadays we are here, more than 500 attendees at this RISC-V Summit, so it really happened. But back in 2015 we founded the RISC-V Foundation together with 24 other companies, we built our own RISC-V implementations.
Okay.
For us, portability was important, flexibility was important, but also it should be standardized.
Yeah, now I understand, because RISC-V plays a very important part in this solution, but this is a secure solution. You're working together with the NLR, which is the Dutch space industry. You're working together with universities. So this solution is not just open. So basically from RISC-V, which is an open solution, you have been working towards a sort of a closed solution, which basically allows you to, to stay in contract and terms with your confidential partners.
Yes.
So that's also possible.
I think RISC-V means it's an open standard. It's not necessarily open source. Of course, from the open standard you can build open source implementations, but you can also build closed source implementations. Sure. For us, especially in the security domain, certification is really important. So certification bodies, they need to know what has been built. So if you base it on an open standard, they know what it should look like. So that's really important. And it also gives you transparency. in some way or the other to the certification bodies.
Yeah.
But for us, yes, it's really a closed source implementation. Of course, we work together with research partners, with other industries, because this is also a complex domain. You cannot do it alone. So you need to collaborate in an ecosystem.
Yeah. Now, this is bound to happen somewhere in space. Is it already in space, your solution, or is it? What are the plans?
No, so it's not in space yet. We started this idea in the Netherlands because in the Netherlands we're very good in optical sensors, for instance for gas detection in the atmosphere out of space. But in the Dutch supply chain for space, there is a missing link, and that's the space avionics, the space electronics. So with our expertise of modular electronics design and HL FPGA design, we said, okay, we can bring that expertise to space, and we can really build reliable, secure electronics. So that's actually where the journey started. With the support from the Netherlands Space Office, we got a first project to demonstrate that this concept could work. So we now have an TRL-5 demonstrator where we integrated an engineering model that we got from Esron Airbus, and we demonstrated that the concept could work. And now we are in discussion with the stakeholders from industry to really bring this concept to flight electronics. So I hope within 1.5 years from now we really have the flight electronics available.
We should talk back and meet back in 1.5 years then and see if all the plans.
For sure.
Okay. Thank you very much for the information. I hope the research and the plans go well, and that your product indeed will end up in space then.
You're welcome. I hope so.